Okay, in question 5 we're looking at an important problem in economics where we're looking where supply meets demand, and we're calling that the equilibrium point here. So here we have an equation here for supply, let's call that equation 1, and an equation for demand, let's call it equation 2. So before we start trying to work this out, let's see if we can visualise what this actually looks like. Now these two things are positive quantities, so if we can graph this, so just like we do a normal equation, but instead of y we have p here, and x as usual on the horizontal axis, and we can graph what these look like. So we can see here the y-intercept would be 60 for one of them, for the supply, and it's a positive slope, so the line's going to look something like this for supply. And for demand, well, demand, the y-intercept is 80, and we have a negative slope this time, and slightly smaller, so it's not going to be as steep, something like this. So that what we're looking for is this point here where supply and demand are equal. And so that's exactly what we're going to be doing with our algebra. We're going to make these two equations equal, so they're both equal to p, so we can make them equal to each other. We can say that 60, let's write this exactly the same, plus 0.0012x, that's going to be equal to the demand at this point. So the demand was 80 minus 0.0008x. So what we'll do is we'll combine the like terms here. We've got 0.02, or that decimal for x, and this one here for x as well on the right hand side. We're going to add them together, so we'll have 0.0012. Be careful with the number of digits here. We're going to add 0.0008x, and on the right hand side we've got 80, and we're going to be subtracting 60. Okay, so that's nice and easy. That's 20. So when we add these two together, well, it's the same in the first two digits here. So when we add the rest of the parts together, it's going to be 20. So we can simplify this, or you can do it longhand if you like, lining them up. 0.002x. So convince yourself that that's true. All right, so now we want to get rid of all of these decimals, so we can multiply it 1, 2, 3 times. So that means multiplying by 1,000. And we'll do that to both sides. This is just to remove the decimal to make it a little bit easier. So now we'll have 2x equal to 20,000. 20,000 there. Okay, so x, we can see, is going to be 10,000. So we've got, right now that tells us the x coordinate of the equilibrium point. So 10,000, and let's call this one equation 3. So we now want the value of p here for the other point in the coordinate. We want to substitute 3 into equation, and let's use equation 2 is going to be slightly easier for this one here. So if we do this, we'll have p equal to, just writing exactly the same as 2, 80 minus 0.0008, and instead of x we're going to multiply by 10,000. So remember, multiplying by 10,000, we're moving the decimal place 4 spaces, so 1, 2, 3, 4. And so this number here is going to be 8. P is equal to 80 minus 8. Should be able to see that that's 72. So there's the coordinate for our equilibrium point. And let's check our answer here. Yes, it's the same. As an exercise, you can try this on your graphic display calculator. Graph both equations. You can use, instead of p, you can just write y, and then find the intersection